Hi, in this video I am going to discuss about the shear force and bending moment diagram, right? So first of all we'll see what is the beam. Okay, so beam is what? The beam is nothing but it is a structural member which is used to carry the transverse load, right? So when I say the transverse load means the vertical load. So first we'll define the beam. So beam is what? That beam is nothing but structural member which is used to carry the transverse load. Okay, and beam is of member which is used to carry the transverse load, right? Then we have a types of beam, right? So we have a 5 types of beam. Basically, first one we have a simply supported beam. So simply supported beam means what? The simply supported beam is nothing but the beam which is simply supported by the two ends. Okay, which is simply supported at the two ends. These are the two reaction is having at the two ends. So this is the simply supported beam. So this is RA and RB, and the length is having L. The second type of beam we have, which is the cantilever beam. So cantilever beam is what? The cantilever beam is nothing but the beam which is fixed at one end and the free at the another end. That beam is known as the cantilever beam. So cantilever beam is the beam which is fixed at one end and the free at the another end. So that beam is known as the cantilever. Third one we have a fixed beam. So fixed beam is what? That fixed beam is nothing but the beam which is fixed from the both ends. So that type of beam is known as the fixed beam. So this is the fixed from both ends. So it is the fixed beam. We can give the name that is A and B. Fourth kind of beam we have here, which is continuous beam. So continuous beam is what? The beam which is having more than two supports. Here we see the simply supported beam. So in simply supported beam, at the two ends the supports are acting. So but in the continuous beam we have a more than two supports. Okay, so this is what? This is the continuous beam. So continuous beam is one which is having more than two supports, maybe 3, 4 like that. Okay, so this is the A, B, and this is C. So reactions are RA, this is RB, and this is the RC. The fifth one, which is the overhanging beam. So overhanging beam is what? The beam which is extended beyond the support. Okay, so that type of beam is known as the overhanging beam. Like this is one portion and this is one reaction and it is another reaction. So this is the name A and this is the name B, and this much of portion beyond that support B, that much of portion is extended. That portion is known as the overhanging portion. So one more point I would like to add, that it is not necessary that only from the one portion will be extended. It may be from the both end the extended portion we have like this. So this is one reaction and this is another reaction. So we have extended from the left support as well as from the right support. So this is the overhanging beam. As we have discussed that 5 types of beam we have, then how many types of load will act on the beam? So there are the 3 types of load we have which will act on the beam. First one is what? The first one is nothing but we have a point load. Okay, or the point load is also known as the concentrated load, right? So point load, or we can say the concentrated load. So point load is what? The load, point load is nothing but the load which is acting at a particular point. So this is, we have a point load. So suppose this is the simply supported beam and the load, this load W is concentrated at a one point. So that load is known as the point load or concentrated load. Second types of load we have that is uniform distributed load. So uniform distributed load, right? Or in short we can call it as a UDL. So UDL means what? The uniform distributed load means the load which is distributed across the length. That load is known as the uniformly distributed load. So this is the symbolically we can represent the UDL like this, that is W Newton per meter, means W Newton of load is acting up to 1 meter of length. Okay, so this is one beam, we have A and B, these are the two reaction and it is having length is L. Now while we solving the problems and the UDL is given, first of all we have to convert this UDL into point load. To convert this UDL into point load, we need to multiply that given UDL with the length. Okay, up to what length the UDL is acting. So in this problem, in the given figure, the UDL is W Newton per meter and it is acting up to a length of L. It means what? As we have to convert this into point load, it means W into L. So it becomes Newton. That it means it became the point load. Then the question is arising where this point load should act. So this point load will act at the center of gravity of the beam. Means center of gravity of the beam means up to what portion it is acting. So center of gravity of the beam. Okay. So it is acting means L by 2 we can say, right. In the third one we have a UVL, that is uniform varying load. So uniform varying load. So uniform varying load means what? The load which is varying from point to point. Okay, so that load is known as the uniform varying load. Suppose this is one beam, we have A and B, these are the two reaction. Okay, and then here the UVL is like this, as it is varying from the point to point, so it will be like this. Okay, so this is the, we have a UVL. As we see the, look at this figure, then we'll get the triangular shape, is it or not? So if I'll consider the length of the beam is L and at this point the magnitude is W Newton per meter is acting. Okay, so in this case if I want to know how much load is acting over the beam, so this is the area of the triangle. So area of the triangle is what? Half into base into h, base is L and the h is maximum load, that is W. So area of triangle we can say this is half into W into L. It means that WL by 3, and then the question is arising where this WL by 2 will act. So it will be act at the 2 by 3, 2/3 of the length. Okay, means this load will act at the 2/3 of the length of this beam. Okay, next we'll see the sign convention for the SFD and BMD. Thank you.